for the area calculation, that's going to be the 4 minus x squared minus x plus 2 times dx. And if you did some algebra and a little bit of calculus and a little bit of arithmetic, you would have numbers for all of this. Any questions on this one? Oh, that's why you all give me funny looks. So I was thinking about the last problem. About negative 2 to 1. How's that? Yeah. So we followed it, just like Newton when he was looking at all the different distances from the Earth to the Moon. He said if he collapsed the entire Earth into the center and collapsed the entire Moon into the center, I could just use that distance. So same idea, so I'm just collapsing this entire mass into the one point. So, as I decided, so 7, 8, we didn't get to that on the last test, and I accidentally included that question. So I decided I'm going to move 7, 8, it's going to be on your final exam. Is your first question on this exam is 6.1. Actually, before I do that, homework questions? Okay. So let's do, you guys got a couple, we'll do those. And your exam is going to start at 6.1. It's going to do all the chapter 6 stuff that we did. I think 6.1 to 6.5, and then 8.1, 8.2, and 8.3. 6.4 I think was average value. Average value? 8.1 to 8.3. So we'll work on some homework and talk about how we work on themselves. So be relevant to the exam. And then I'm sure we'll have leftover time. I'll do a problem, we give you another problem.
How did he get 2? So why the average is 2? He just pointed.
Why is the average 2?
Yeah.
No, so
Yeah, the one that you pointed.
Yeah, right here. So how do I find the average of 2? Yeah. So see why is this number 2?
Yeah.
So how do I find the average of 2 numbers? So how do I find the average of 3 and 11?
Oh, you minus?
No.
No.
So take the average, you add them up and divide by 2.
Oh, I see.
You see it?
So why divided by 2?
Can I answer? Or try to help? The number of numbers that you have, that's the number you're going to divide by. So if you had 3 numbers, it would be 3. If you had 10 numbers, it would be 10. If you had n numbers, it would be n. So he divided by 2 because he had 2 numbers that he's averaging.
Okay, like 4 minus x squared minus...
Okay, so that's different. There's 2 different things going on here. There's the distance to the center point. And the distance to the center point is the average of these 2 y values. Okay, also another calculation I need to make is the area, which is the base times the height. And the height of this is going to be the difference between these 2.
Oh,
Should we talk more or we good?
yeah, very good.
Okay. Maybe? Let's see. Yeah, so first of all, that's going to be, if you want a number for your answer, not just points. So x cubed over 2 and 1 over 6x. And what are the range of x values? 1 half. And then 1. And are we rotating around the x-axis or rotating around the y-axis? And let me just point out something. So in homework problems that come from calculus books, you're going to see weird functions like this. Where do functions like this show up in real life? The short answer is they don't. So why did they choose this weird function? Is because when you get to the integral, it'll actually be an integral you can do with techniques that you learned in chapter 7. Or realistically, you'll have a more normal function You won't know how to find an antiderivative of that function. So what would you do if you can't find an antiderivative? Oh, okay, Wolfram. That's true. And what's Wolfram doing? Is they're doing one of the approximation methods. So the midpoint rule, the trapezoid rule, Simpson's rule. So this is an 8.2. This is 8.2 number 1 from WebAssign. And we want to rotate this around the x-axis. We make some shape here. Luckily, I don't need to worry too much about what that shape looks like. And if I'm rotating around the x-axis, what I like to do is extend